Okay, let's talk about Chapter 4, Section 5, which is special applications of percent calculations. We're going to focus on the following special applications of percent: discount, sales tax, interest, commission, efficiency, tolerances, and percent change. So, an important kind of percent problem, especially in business, involves the idea of discount. To stimulate sales, a merchant may offer to sell some item at less than its normal price. A discount is the amount of money by which the normal price is reduced. It is a percentage or part of the normal price. The list price is the normal or original price before the discount is subtracted. The net price is the new reduced price. The net price is sometimes called the discounted price or sales price. It is always less than the list price. So we've got a formula here that says that the net price is equal to the list price minus the discount. Well, a discount rate is a percent number that enables you to calculate the discount, the percentage of part P as a part of the list price base B. Therefore, the percent proportion is part of the base over that is equal to rate times 100. So our discount over our list price ends up being our discount rate over 100. The list price of a tool is $18.50. On a specific sale, it is offered at 20% off. What is the net price? Okay, and remember that the formula above said that the net price is equal to the list price minus our discount. So we know what our list price is. Our list price is $18.50. It tells us that in the problem. Okay, and the discount is 20% off, but we need to know what actual number that is. So we need to find out the discount. So we've got, if we follow this formula up here, right, we've got the discount rate, and I know that that goes right here because a rate is what has your percentage sign, so our percentage over 100. Now our discount is what we don't know what that price is, but we do know that the list price is $18.50. So if we use our cross multiplication, we're going to have 100 times the discount is equal to $18.50 times 20. Okay, so 100 times our discount is equal to $370. And then when we take that and we finish solving the problem by dividing by 100, we would have that our discount ends up being $3.70. So to find our net price, we're going to want to subtract these two things. So $18.50 minus $3.70 would give us $14.80. Okay, they've given us an example up here about a different formula that we can use. And let me just talk about this real quick. I'm going to use this in the example. So after a 25% discount, so if you're getting, let's just think about it this way. If you're getting to take 25% off, then you're getting charged 75% of the price, because these two numbers have to add to 100%. And it says the net price of the 5-inch random orbit sander is $57. So this is the price after the discount. And so what is the list price? So what we know is that the $57 actually represents 75% of the price. Because we got a 25% discount, we only had to pay 75%. So those two things would go together. And we don't really need to put the percent here. So if we're looking for, what would be the total price? What is the list price before the discount? This is our discounted price, and that discounted price was only 75%. Then what is our total price if it was at 100%? So we would say 75 times X is equal to 57 times 100, which is going to be 5,700. Divide both sides by 75, and we would get 5,700 divided by 75 ends up being 76. And so if you did 76 times 0.25, that number is 19. So if you take 76 and you subtract 19, just to check our work, 76 minus 19, you would get the 57, which is what they said that our sale price was. So that's just another method. A kitchen sink that retails for $884. So this is the total cost, right? It's offered to a plumbing contractor for $574.60. What discount rate is the contractor receiving? So this plumber is getting a sink that started out being $884, and they're getting it for $574.60. So we kind of want to figure out, well, what part are they actually paying for? So what are they paying for out of 100%? So we would multiply this stuff. $884x, when we look at this side, that's going to give us divide by 884, and so x ends up being 65. Okay, now that is the part that we're having to pay. So we're saying that we have to pay 65%. So that's what we're paying. So the discount would be 100 minus 65, which would be 35% would be the discount. In some situation, multiple discounts are given on a purchase. These discounts are usually applied in succession so that each additional discount is applied to the newly reduced price. So an example would be retail buyers often negotiate 2 or more discounts from a vendor. Suppose a washing machine has a list price of $740, and the buyer obtains trade discounts of 30% and 10% plus a cash discount of 3%. So in this case, they're going to take the first discount off, and then they're going to apply the second one, and then they're going to apply the third one. They're not going to they're not going to add 30 and 40 and 3, right, for 43% discount. They're going to figure out the first cost, and then so let's do that real quick. So they're going to say 740. If we're losing 30% of the price, that means that we're keeping 70% of the price, which is 0.70. Well, now we're at 740 times 0.70. Now we're at $518. Well, they said of that, now you're only going to pay 10% of that. So we're keeping 90% of the cost. So 518 times 0.90, we're at $466.20. And then it says, plus we're going to get paid, if we pay with cash, we get another 3% discount. So if we're getting to take 3% off, we're keeping 97%. which ends up being $452, and it's 214. Now remember, with money, you always want to round up. So 452, it doesn't matter if it's 5 or bigger, it's going to be 22 cents. Using the proportion method for solving percent problems makes it easier to distinguish among the different types of problems. However, it seems that most practical applications involving finding the percent or part, and there's a quicker way to do this, especially using a calculator. Simply change the percent to a decimal and multiply by the base. So we've got 20% of $640. Step 1 would be to change the percent to a decimal. So we're going to take 20% and write it as 0.2. Now multiply this decimal equivalent by the base. 0.2 times 640 is $128. This is the same answer you would get using a proportion. So if we wanted to do our part over 640 over 20 times 100, it's the same method. It's just a different, this is the same answer, just a different method. And once again, it doesn't matter which one you want to use. So taxes are almost always calculated as a percent of some total amount. Property taxes are written as some fraction of the value of the property involved. Income taxes are most often calculated from complex formulas that depend on many factors. A sales tax is an amount calculated from the actual list price of a purchase. It is then added to the list price to determine the total cost. Retail sales tax rates in the United States are set by the individual states, counties, and cities and vary from 0 to 10% of the sales tax of the sales price. A sales tax of 6% is often stated as 6 cents on the dollar because 6% of the dollar equals 6 cents. So we've got our sales tax over our list price is equal to the tax rate over 100%. Our total cost is our list price plus our sales tax. So if the retail sales tax rate is 7.75% in a certain city, how much would you pay for a digital multimeter with a list price of $76.50? Okay, so you can absolutely use this formula, and that's okay. If I'm paying sales tax, then I know that I'm paying over 100% because 100% of the price is going to be this. So I automatically change this to, I'm paying 107.75% of the price. And so when we write that as a decimal, if we move our decimal over twice, it would be 1.0775. And so we could just multiply by that number, right? And we could get the answer that way because it's asking what would the total cost be? Well, we're paying over 100%, so I would multiply by 100 plus the 7.75%, and when I change that to my decimal by multiplying by 100, when I change my percentage to a decimal, I'm going to want to divide by 100. So 107.75 divided by 100 got me the 1.0775, and that would be the answer if we did that. Okay, and that's going to be $82, and it's 42875. So remember that we're talking about money, so we always round up. So $82.43. So this is what they were saying. It's a quicker way to do it, and this is the formula that they're using that's similar to what I just did. In modern society, we have set up complex ways to enable you to use someone else's money. A lender with money beyond his or her needs supplies cash to a borrower. the money is called a loan. Interest is the amount that the lender is paid for the use of his or her money. Interest is the money you pay to use someone else's money. The more you use, the longer you use it, the more interest you must pay. Principal is the amount of money lent or borrowed. So here's a formula for simple interest. And suppose that you have $5,000, and I will say this, most credit cards, bank loans are not simple interest, they're compound interest, but we're going to just talk about a flat, simple interest rate. So suppose you have $5,000 in a long-term CD, and it's earning 1.25% interest annually in your local bank. How much interest do you receive in a year and in 9 months? So what we know is we're starting with our $5,000. Well, we're going to get back what we already had. So if we get back what we already have, we're going to multiply by 1. And in addition to that, we're going to get back 1.25%. I want to change that to a decimal, so I'm going to divide by 100, which would be 0.0125. And I'm going to add that part onto this. Okay, and then since it's going to happen, and so we're going to multiply this by 1 because we're doing this for 1 year, and we get $5,062.50. Now, when we look at this and we're multiplying, we're going to know what happens in 9 months. And the interest, I guess this is our total, right? So we started out with $5,000. So to get just the interest part, we would want to subtract those two, and we would see that we got $62.50 interest in 1 year. Well, to know what we would get in a quarter of a year, we would need to multiply that by 3/4. So I'm going to take my $62.50 times 3/4, and that's going to get me 46.875. Remember that we can only have 2 decimal places. We're talking about money, so we're going to round up. So commission, let's talk about commission. Commission is that part that you make on top, like if you sell a vehicle and you get 5% commission for that. That's what you make for selling something, right? So a computer salesperson is paid a salary of $800 per month plus a 4% commission on sales. What amount of sales must he generate in order to earn $40,000 per year in total commission? Well, or in total compensation. Well, what we know is that he already makes $800 per month, okay? And 800 times 12 ends up being $9,600. So we've already got that taken care of. So 40,000 take away 9,600 ends up being 30. So 40,000, sorry, minus 9,600. Yeah, $30,400. So this is what the person has to earn in commission. So the question is, what amount of sales must he generate in order to earn that? Well, he only gets 4% for commission. He needs to make that 4% of whatever he sells needs to be equal to 30,400. So we would do our cross multiplication. So 30,400 times 100 is equal to 4x. So when we divide that by 4, $760,000 is what he needs to sell in order to get that 4% commission that's going to get him up to his $40,000. Efficiency is also something that's important. So we want to know, when we want to know how efficient something is, we want to look at the output over the input, and that gives us our efficiency over 100. An auto engine is rated at 175 horsepower and is found to deliver only 140 horsepower to the transmission. What is the efficiency of the process? So we're looking for the efficiency. If you look at this formula, we're looking for the efficiency. We know that the auto engine is rated at 175 horsepower and is found to deliver only 100 horsepower to the transmission, 140 horsepower to the transmission. So this is actually what the output is, 140. The input is 175. And so do our cross multiplication. We would get 175x is equal to 140 times 100. Okay. And we're going to divide by 175 on both sides. And so 14,000 divided by 175 is going to give us 80. So it's actually 80% efficient. On technical drawings or other specifications, measurements are usually given with a tolerance showing the allowed error. So something could be plus or minus, so it's like in a range. This means that the dimensions shown must be 1.370 plus 0.015 inches, and it could be up to, or it could be as low as 1.37 minus 0.15 inches. Okay, so these are the tolerance limits. It needs to be between these two things. If we added 0.015 or if we subtract 0.015. And so we've got the tolerance over the measurement is equal to the percent tolerance over 100. So the example that we've got, to rewrite this, 1.37 plus or minus 0.015 with 8% tolerance. Substitute into the proportion equation and solve as follows. So the 0.015 is our tolerance over our measurement. We would get the percent tolerance over 100. And so they've done the cross multiplication and then they've done the division, and they end up with 1.09% if they round. So the dimension would be 1.37 plus or minus 1.09%. Okay, here's another example of the tolerance. We've got 315 plus or minus 0.25 millimeters can be converted to percent tolerance. So we've got our 0.25 over our 315, which is our tolerance over our 100. So they've cross multiplied and found out that it was 0.08% whenever they rounded. Okay, so they've got an example of a problem that says, suppose the output of a certain electrical circuit is 20 amperes and the output increases by 10%. So that would be the percent increase. What is the new value of the output? So they've got the amount of the increase over the original amount. So we don't know what the amount of the increase is, but we know that the original amount is 20. The percent increase is 10 and over 100. So they did their cross multiplication and they found out that it was 2 amperes. Well, if it started at 20 and it increased by 2, the total is going to be 22. So this next problem says, suppose that the output of a certain machine at Acme Gidget Company is 600 gidgets per day. If the output decreases by 8%, what is the new output? So our percent decrease is 8%. The way that they work that last problem is if we're starting out with 600, that would be our total. We're looking for what our percent decrease would be, and it says that the output decreases by 8%. Okay, and we don't really need the percent sign up here, and so we would do 8 times 600 is equal to 100 times x, and 8 times 600 is 4,800. So when we divide by 100, we would get 48 is equal to x. Okay, and so we started at 600, and it says that we're going to decrease by 48, and so that's going to leave us with 552 gidgets per day. We can also solve the problem by subtracting the percent of decrease at the beginning of the problem and then finding the new value. That would probably be faster. Okay, so if the reading on a pressure valve increases from 30 to 36, the percent increase can be found by using the following proportion. So to find percent increase, you always do the big number minus the smaller number over the original amount. And so if the reading on the pressure valve increases from 30 to 36, then our original amount would have been 30. So 6 over 30. So you're going to do 6 divided by 30, which is going to give us 0.2, which is 20%, would be our percent increase. During the recent drought in California, certain water districts were requiring residents to reduce their water usage by specific amounts. The Jones family lived in a district that required residents to reduce their monthly usage by 30% compared to their average for the prior year. Suppose their prior year average was 36,400 gallons per month, and they reduced their usage to 26,800 gallons per month for the first quarter of the current year. To determine whether or not they met the district's goal, we set up a percent decrease. So remember that you're going to do the bigger number minus the smaller number divided by the original. We started out with 36,400. So 36,400 minus 26,800. So we get 9,600 divided by 36,400. Okay, and that is going to give us approximately 0.263736, kind of repeats like that. So this would be 26.37 approximately if we talked about the percentage, if we move our decimal 2 places. Okay, and it said that we needed to reduce their monthly usage by 30%, so no, they didn't meet the goal. They did not meet the goal. Okay, students are often confused about which number to use for the base in the percent change problems. The difficulty usually arises when they think in terms of which is bigger or smaller value. Always use the original, so that's why I was saying big minus small. So the bigger number minus the smaller number over the original, the first one you come to. A house purchased for $400,000 during the housing boom decreased in value by 30%. By what percent must it now increase in value in order to be worth its original price? So let's figure out what that is. So 400,000. So remember, if you lose 30%, you are keeping 70%. So I'm going to get that calculation real quick. So 400,000 times 70% or 0.70 is 280,000. So that's how much the house was worth after, and we want it to go back. So the question is, by what percent must it increase to be worth its original purchase price? So So 280,000 times what number is going to get you 400,000. So if we divide that, 280,000 on both sides, we're going to get $1.428. It kind of keeps going like that. So in order to get back at least our original, we're going to have to do, if we look in just to 2 decimal places, the 1 would give us back our 280,000 we started with. We're going to have like 43%. We round up there to get back our 400,000. So 280,000 times 1.43 gives me $400,400. So, and that's kind of crazy to think about how percent increase and decrease works, because you would think it would just be your 30%. That's the end of section 5 in chapter 4.